hate Yorkville.
I don't understand. I mean, it's hard.
I hate Yorkville. It's like PowerPoint,
Who doesn't
right?
hate Yorkville?
Yorkville. You know the best thing that ever happened to Yorkville? I-88.
Oh, this was on construction.
I don't know. I don't know. Can you get to Yorkville on I-88? I'm sure you can. We're saying you get out of Yorkville.
I get it.
You know what she's the worst? Sterling. Have you ever been to Sterling?
No, I don't think so.
Yes.
You are lucky.
Yorkville needs to just ride.
I would say that probably one of the worst schools that I went to for swimming was the old Woodstock High School.
Oh, hey, I'm going to Woodstock today.
Oh, that's cool.
That's cool.
Well, you'll probably go to the new Woodstock. The old Woodstock, you probably swam, you might have swam there. They had like a 5-lane pool that's bromine. It's just small and they keep it about 30 degrees. It's
Yeah.
awful.
And
You can't see this far in front of you.
Yeah, and it's extra salty
Yep.
and like makes your skin really super itchy.
Right. They've been doing it because it's cheaper to run salt in it than it is chlorine because it'll last longer and it's just less upkeep.
No, I know exactly what
Yeah, so you've been to the old pool. That place is awful. It's like a dungeon. The ceilings aren't very tall. It's just. Ugh. Anyway, let's talk about some cars.
The only good Sterling has is a giant red flag. They spent the whole budget on a giant red.
Wait, you did that?
Sterling.
Sounds like something Morris would do.
Oh, Morris. Morris is just terrible.
Morris is awful.
Apparently Morris is a decent baseball team. The rest of them.
Yeah, I think baseball's pretty good, but they suck at pretty much everything else.
They only lost one match.
Oh man, you guys are funny. All right, anyway, let's revisit how we talk about combinations of cards. We're not looking at the probability that I flip over and I'm going to get a 2.
No.
6.
No.
Jack.
We got you so good.
Hate you all. So
It was a queen though.
How do we all know how to like react to that?
It's fun to mess
Like,
with
'cause
you.
we're.
Wait, do it again.
no, you're looking at possible combinations out of that 2 lot of million combinations of 5 cards. Remember, we found that to be a lot of things.
A lot.
We're talking about face cards. When we're talking about face cards, we're talking about kings, queens, jacks. When you're looking at the possible combinations out of that 2-something million, how many of them could come up with all 5 of them being face cards? Well, you have to look at it as how many face cards are there?
12.
There's 12 of them. How many do you want?
5.
So the combinations, the total combinations of that occurring, there's 12 face cards, you're choosing 5. Okay? A lot of times people are looking at it as, well, there's 12 out of 52 and you're doing that. What you're doing there is you're thinking 12 out of 52. Well, 12 out of 52 is 6 out of 26, 3 out of 13. So every 3 cards out of 13 should be a face card. And 3 cards out of 13 being a face card, is that theoretical or actual probability? It's theoretical, yes sir.
So is that going to be your answer?
Whatever that equals out to be.
Yeah.
What is it?
it's 7. I thought it was
So my theoretical probability of getting 3 face cards,
1, 2, 3, 4. You did.
so I did better than the probability. Remember, a lot of times people, when they start first looking at these combinations, permutations, a lot of people tend to think of them in terms of probabilities, like how I saw with you before, and it's kind of what you were doing. You know, it's very common. You aren't the only one. A lot of people do that. Okay, and but now you start to see, okay, you're talking about combinations. The next one, you have 4 aces and 1 other card. Well, how many aces are in a deck of cards?
4.
How many do you want?
4.
4 of them.
4.
Now, look at how this is written. You want 4 aces and 1 other card. I got to multiply something here. So you want 4 aces. How many aces are in a deck of cards?
4.
How many do you want?
4.
4, choose 4. Times. The reason why it's going to be times is because you want 2 things to occur.
I had
How many cards that are not aces are left? How many do you want?
1.
Alright, I got that. What's the answer?
Some number.
I got 48.
48.
Yeah, it's 48. Wow.
There's
Great
48
chance.
combinations. Because think about it, you have 48, only 40, it's not a chance. It's only 48 combinations that can occur. It's basically you want all 4 aces. So you get all 4 aces out. So you have all 4 aces now. You want one other card. Well, how many other card combinations can there be for that last card? Here's 1, 2, 3, 4, 5, and so on and so forth. There's only one way of getting all 4 aces. All 4 aces have to be there. It's just all 48 others. So that's a total, that's how that works out.
48.
Yay!
Wait, 48 pickups.
Okay, yeah, 48 pickup. You want 1 ace and 4 other cards that are not aces. This is 4, choose 1.
51, choose 4.
Ah,
Oh wait, it can't be an ace, just kidding.
very good. So you have a 4, choose 1, and then you want 4 other cards that are not aces.
48, choose 4.
Very good. And this is a multiply again. And why is that multiplying?
Because you can.
Excuse me.
What's the word?
And you get 778,000.
Sure. Whole lot of whole lot of deals.
778.
Now in this one here, we have
783. 783.
we have 2 aces and 3 kings. How many aces are there?
4.
How many do you want?
2.
How many kings are there?
4.
How many do you want?
3.
Do you multiply or add?
Multiply.
Multiply, because you want those 2 events to occur at the same time.
You get 24.
That's a lot worse than
How do you do 30?
How do you do 30?
Yeah, that's confusing.
30 is extraordinarily confusing because you need to think about one extra step that's not shown. When you want 4 of one kind and 1 of a different kind, that means you have to figure out, first of all, which kind are you going to get? So we're talking about kinds here. Bless you. How many different kinds are in a deck of cards?
13.
13, good. So you pick
1.
a kind.
So 13. Wait.
So you pick the kind. So you pick the 7.
So it's 13, choose 1.
Okay, so once you get your first thing that you're choosing here is you want 13, choose 1. You picked it.
Time.
Times. Now this is the one that gets a little weird. How many of those cards do you need?
4.
How many are you going to choose?
3.
Hold on. You chose 1, but you want all 4 of them. So you pick the suit, you pick the card, say, okay, I want to pick 7. I picked a 7. I want all 4 of them, so I have to pick 4, choose 4 of these, which is, in essence, that's just 1. But it's easier to see that once you pick, I want to get all 4 6s.
Yeah.
It's not. It's upside down 6.
Yeah.
No, like legit, that's 6.
Can't trust us.
It's like the one who tried wolf.
And then, so we picked all 4 of them, and then what do we have left to pick out of?
Okay, so I'm confused on, okay, so I understand you're getting the 13 from like suit,
Mhm.
but why do we have to pick up the suit?
You have to pick, it's not the suit, it's just picking 2 through ace. Picking a card. I want to get, well, how many combinations are there of me of getting 4 3s as well as some other card?
Oh, because there's 13 cards.
Yeah.
There's 13
You're
total
not picking a
cards,
suit, you're picking a
Okay.
card value.
and then I want to get all 4 of those,
There's 13
Okay,
and then I want 1 other.
okay.
So it's kind of like, I want to get all 4 of the same numerical value, but in order to decide that, all I have to do is just pick a card, and then I want all 4 of them. Yes, sir?
So you have to
So when
multiply
it
it
was
by
4 choose 4, wouldn't it just be like, because there's only 3 left after you choose the first one?
Remember, I'm not choosing it yet. What this is all, what I'm putting in here with this 4 choose 4 is saying that 4 choose 4 is equal to 1. Okay? In the book, They just say it's 13 choose 1, 48 choose 4. I'm sorry, 48 choose 1, excuse me. Because you only wanted one lot. I thought that by putting that, you pick 4 of them, in between them, it would be a little bit cleaner to see why that works. Third hour, I thought, oh, that makes sense, because you're getting all 4 of them, and then 4 choose 4 is 1. It's just a little, it's like a buffer between the two to show why is it going from initially saying, how many combinations are there? Getting all 4 3s and some other card. That's what I'm looking at. It's a little bit different than getting all aces and then, or 4 aces and then 1 other card. I want to pick 4 of just one kind, and I'm opening it up to all 13 of them. Once I pick 1 of them, I got to get all 4 of them, and then I got to get 1 other card. Does that make more sense? Like compartmentalizing it or decompartmentalizing it? Breaking it down. I will do that. No, and then there's to be a 48 choose 1, I believe, at the end.
So 624.
Sure. Actually, it's 1126, but that's okay.
What?
Water bottle.
That's fine.
Okay.
I
Sure, whatever.
Wait, is that what you said?
Whatever.
You just said the.
I didn't.
It's 624.
No, it's 1126.
1126, because that's like the time.
The answer is 624.
624.
I'm getting all these answers wrong.
All right, how are the word problems? How we do?
50.
You know it's bad when you say how'd you do and they just start yelling out numbers and problems.
I just did not understand the whole concept.
50, I think out of all of these, 50 is the weirdest.
Really?
50 is the weirdest, I think. Because they give you information up in the front, but then they ascribe to the information of what you're supposed to do at the very last sentence. There are 6 artists presenting 5 works of art in an art contest. We know it's not me because I can't draw. The 4 works judged best will be displayed in a local gallery. Huzzah! How many ways can these 4 works all be chosen from the same artist's collection? Now, listen, I heard you mention what you did first. What was that again?
6 choose 1.
Why did you say 6 choose 1?
Because like they all have to be from the same artist, and then 6 artists, so you have to pick 1 artist.
And then what did you do?
And then I did 5 choose 4.
Perfect. Did you add or multiply?
Multiply.
Very good. What you have to do there is, as you read that, there are 6 artists, and you want to get, yes, it's perfect. Very good. And you want to get 4 of their artworks into the gallery. So how many different ways could that occur? Well, you have to first pick the artist, and then get 4 of the 5 artists artworks they have. Sure. Okay. What else do you want to look at?
Wait. If it's up here with the fish.
The fish?
So all of them.
Oh, that just took forever to write out.
I did this on a bus on the way home from a game, so I wasn't very focused, I'd say.
You're on your phone.
No, I was doing my homework. I told everyone to shut up and then so I could do my homework. Oh, I'm sure that one.
I'm sure that helped a lot.
Fish one, I love the fish one.
So the fish one, if you read it, it says, from the list of different species of fish shown, an aquarium enthusiast. Sounds like a 4-year-old. No offense. Is interested in knowing how compatible any group of 3 or more different species are. In other words, don't throw it out, you should recycle that and refill it.
Actually, the more that you put water into the water bottle, the more
Okay, Debbie Downer.
She's saving my life. Hey, this is going to be reused, so just reuse as something different, and that way they won't have to recreate more plastic from the environment.
Does it?
It better.
I hope it does.
I hope it does. All right, so You want to make sure that the red platypus doesn't eat the zebra, and the catfish doesn't eat the angelfish, and the neon tetris doesn't eat the zebra, and the tiger doesn't go after everybody. So you want to make sure that they're friendly before you try to mix them all together.
How is that relevant?
That is
Now, what happens here is that you have how many different combinations are there to consider, because you want to have groups of 3 or more. Yes, ma'am.
I think there's a total of,
There's 10 fish.
there's 10 fish, so there's a total of like 8 groups.
Correct. That's exactly what you're looking at.
Wait, hold up.
Wait, what?
Take a look at what's happening.
Because you have to
If
add-
you're doing 3 or more, which means you can have 3, 4, 5, 6, 7, 8, 9, or 10 fish, right? So there's 8 different things that could occur. You're not all 8 of them are going to occur at the same time, are they? So you're going to be adding them throughout. So it's going to be a 10 choose 3, 10 choose 4, 10 choose 5, and so on.
Oh.
It's just 8 of them.
You'll
So
have
you-
10 choose 4, 10
So what you're doing is you're going to do the 10 choose 3.
Will your 10 choose 10 at any time?
Yeah, that's the last amount. And since not all of those events can occur at the same time, you have to add them all together.
How interesting.
Sure.
What is it?
I got 120 when I was
I got 122. It's adding.
Yeah, we did.
Hey, 120, 122 is pretty close.
Oh, so
I was thinking that too.
Don't think too hard on that one.
120 and 122.
120.
They got 122.
TOO.
Oh.
You got that too?
TWO.
122?
I'm going.
Yes, sir.
When it's more or at least, you just add from that number up,
Yep.
like that least
Yep.
number through all the
Yep.
ones, so like the 20 would do 12 choose 4, then 12 choose 5.
Yeah.
I need to write also.
Yep. It just takes a little bit of time to write them out. That's all. It's not a big deal. It's not like it's difficult. Okay? No, I want to add to it. I'm going to add to these today. Okay? Let's talk about, are we okay on these then?
Yes.
All right. Let's do this then. Let's add and start talking about binomial expansion with Pascal.
Binomial nomenclature. What is that?
That's how you make that. That's the scientific name.
Oh.
Yes, it's still the same section.
I had that name in my head, and I kept thinking of it, but I didn't know what it meant. I was pitching it, all I could think about was binomial.
All right, does anybody trust Allie?
No.
Okay, you and I are playing. This is for amount of homework.
Oh, God. No, it's what game is that? Like blackjack?
Yes.
Okay.
Wait,
Why is she going?
She's playing blackjack.
Okay. You know how, so what do I do?
Do you know how to cheat at
I think I
blackjack?
know.
Look at the
But then-
card.
Okay, wait.
Oh,
How is this going to decide I'm on it?
Oh.
Stay.
I'm gonna stay.
So you're at 19 then.
Bro.
I'm at 18. I have to sit. I can't hit.
What?
Do you have 19?
Yeah.
Okay, you win. You get the amount of homework that I was going to give you. Then you don't get more.
Wait.
How'd you know she's at 19?
Because she stayed with a face with an upward 9. She's staying on this. That tells me right now that's a face card. Because if it was a 9, she could have split it apart and doubled down.
What?
I don't know the rules of blackjack.
I don't know.
I was split and double down. I'm so confused.
Gambling.
Whatever, no more homework.
No, you still have homework, just not as much.
Yeah.
Can I come over to your house and we just play it? Thanks a lot, Allie.
Thank you guys.
Hi, guys.
She would have given you more homework if she was hit.
Oh no, Pascal's triangle. We talked about this in AP Euro.
What was the title for
But
it?
I was still in there.
It's the same stuff you did yesterday. It's still 12 too. For those of you guys that had 7 last year,
This was the thing we did with the.
yes, you guys did this with all the ones you start breaking everything through here. And if you remember what happened in Pascal's triangle, what you're doing with you start with 1, and the edges of the triangle are also all 1s going all the way down. The numbers going across are obtained by adding the 2 numbers directly above it. For example,
Oh, nice.
2 is 1 plus 1.
Can you keep going?
1 plus 2 is,
3.
3 plus 3 is,
6.
6 plus 4 is,
10.
10 plus 5 would be,
15.
and so on and so on.
Should we draw that?
No. This is how Pascal's triangle came about. The other thing that happens with Pascal's triangle is that all of these numbers can be rewritten in terms of combinations.
I should write that.
No.
Okay, thank you.
1 choose 0 is 1. 1 choose 1 is 1.
2 choose 0, 2 choose 1, 2 choose 2.
Gives you 1, 2, 1.
1, 2, 1.
Choo-choo.
What happens now is that these patterns always occur. It works on and on infinitely. This is a continuous pattern that will occur to get you coefficient stuff. Now, what we're going to use this for is what's called binomial expansion. Binomial expansion is a real fancy thing for this.
Whoa.
Let's
Big.
begin.
There's some dot, dot, dot in there. I don't think I'm right there. We need to write that down.
No, because that is 7 gazillion, billion, trillion, gadillion times more difficult than it needs to be. Because believe it or not, there's an easier way to do this.
Crazy.
When you're dealing with a binomial and you're going to use what's called binomial expansion, I'm going to start with a term. Let's do it easy. X plus 3 to the 4th power. Now let's say I wanted you to expand that out, FOIL it out. To the 4th power isn't so awful. You'd FOIL it out once and you'd FOIL it out again and you wind up with, yeah, you get big numbers and so on from there. What's happening is that if it's a 4th degree binomial, after you multiply it all out, how many terms would you have? 5. You'd have a 4th degree, 3rd degree, 2nd degree, 1st degree, no degree, which makes it your constant. When you have x plus 2 quantity squared, you get 3 terms, and so on.
And that means
It would hit, no, it's 4.
It just punches the ground.
it'll.
So what's happening here is that you get this pattern to occur. Instead of multiplying it all out, you can do the following. And it only takes about one problem, and you'll see, oh, that's how you do it? It is ridiculously simple. So we start with, this is going to be my A, if you will, and this is going to be my B. My first part of the binomial is the second part of the binomial. So what we do is we take it 4, choose 0, x to the 4th, 3 to the 0. That's my first term. Because what's 4 choose 0 going to have to equal? 1. So what's my leading term coefficient? 1. What's 3 to the 0?
1.
So what's my first term?
Is that 1?
It'll be x to the 4th.
Wait, so you're plugging into the big one?
No, I'm going to make it even easier, but yes, in essence, yes.
Is that 4 choose 0?
That's going to be the
And
coefficient.
then is it raised?
Nope. This is 4 choose 0, x to the 4th, 3 to the 0.
Oh.
Yeah.
Okay.
Plus 4 choose 1, x cubed, 3 to the 1st. What do I do with my powers then?
Wait, you stupid.
You raise
Decrease, increase.
Decrease.
What are the exponents? What do these exponents still have to add up to equal?
It's
They still have to add equal 4. Next one, 4 choose 2, x squared, 3 squared, plus 4 choose 3, x
1.
3
Oh, wait, 3.
plus
4 choose 4. X.
No, wait, no X. Oh, X and 0. Same thing.
4.
Christian, I know you're saying there's an easier way. What happens here is that in ACT, and I think even Park, they're going to ask you at some point in time, what is the 12th term? What is the coefficient of the 12th term of the following binomial? This is how you can do this. It is ridiculously simple. 4th degree polynomial, it's not bad to multiply all out. All right, I'll show you something like the 6th degree here in a second, which makes more sense. Now, we've done this before. 4 choose 0 is what?
1.
It's 1. Okay? So this is 1. 3 to the 0 is what? 1 times 1, x to the 4th. So it's just, the first term is x to the 4th. 4 choose 1 is 4 times 3 x cubed. 4 choose 2.
X squared.
12.
Hold on.
I don't know.
Don't try and do it in your head if you can't.
Yeah.
Once you do these a little bit more, you'll start to remember. Remember, 4 choose 2 is 4, 3, 2, 1 over 2, 1, 2, 1.
I think it's 6.
Oh,
6.
yeah.
So 4 times 3 over 2 times 1 is 12 over 2.
So you get the 6. So it becomes 6 times 9, because that's 3 squared.
So 4
X
4.
squared.
4 choose 3. Yes, ma'am. What's that?
Like the 12x.
I'm just pointing them all out first.
So then the 4 choose
4 choose 3
that's
is 4.
1, 3.
And it's 4 times 27 x.
Give me a second.
And then 4 choose 4 is going to be 1 again. X to the 0 is 1. 3 to the 4th power is
81.
So
Took me
it
way
is x.
So you wind up with x to the 4th, 12x cubed, plus 54 x squared plus 108, yeah.
You're right.
And you're done. It is a very fast way to expand
This
binomials.
would like, because those probably just as fast as if you would FOIL knowledge.
With a 4th degree, yes.
But it would be, this is works better when.
Higher degree.
Well, like when it's higher degree, that means you have to do the plus a lot of times.
Yeah, that's all. But the pattern is the same, and it's really quite simple. I'm going to show you a higher degree one here. I'm going to say x minus 2 to the 6th.
Ooh, I'm ready.
Now, what I want to do here is make sure that you realize what your b value is. It's negative 2. So anytime you have a negative raised to an odd exponent, what does it have to be?
Even. Yeah.
Wait, we don't want a negative.
Negative raised to an odd exponent.
Oh,
It's
negative.
Oh, to the
Negative.
Wait, a negative
But
raised.
this is even.
Oh, this is a negative. Ah.
It's a negative value raised to an odd power is always.
Like negative 2 to the 3rd.
Negative? Wait, why? Are you just asking?
It's negative.
Okay, I'm confused. Why are you asking? Because this is a 6.
It's a negative 2 x minus 2.
But as you go through it, you're going to have to hit odd.
I can't do it.
Allie, what's negative 2 raised to 3?
There's nothing negative or positive. I just need this one.
It's negative. Right? Whenever you have a negative value raised to an odd exponent, the answer will always be negative.
I think we're doing one of the smartest freshmen. And now this is what she's asking. She
Go,
did like
wait,
a cold
here's
towel.
what-
Yeah, that's. Oh, I thought you
Here's
were
what
saying
happens.
this problem. That's an easy
We have
one.
6 choose 0,
Agree.
x to the 6th, negative 2 to the 0. Plus, my next term here, when I'm raising the negative, it's going to go an odd power. Should I make it a minus sign or a plus sign? Minus. Just make a minus sign right away.
Way to go.
So now we have 6 choose 1, x to the 5th, 2 to the 1st. I'm getting rid of the negative there because I put the negative out front. You know what? Here, do it this way. That way you know. All right, that's fine. Just remember, whenever you have an odd exponent, it should be a minus sign. Next one is 6 choose 2, x 4.
Slow down.
Finish it out on your own here, and we'll check it in a minute. Okay? Finish it out on your own and check it in a minute. See how fast this can become?
Yes.
And Christian, and I know this was a question on the ACT just recently, where they gave you like a 9th degree polynomial, and they asked you for the coefficient of the 7th term. So if you had to get a 9th degree polynomial, you want the 7th term, it would be 9, choose 7. X would be, 7th term would be 2b to the 5th, going like that. So you would know how to do that then. It's a clever thing that happens.
Aw, it takes up the whole lot.
Isn't that awesome?
It took up 2 months.
Awesome,
Yeah,
it takes
right,
up
right.
space.
Where'd you get that shirt, Mr. Randy?
eBay. Pretty slick, isn't it? Love it.
Yeah. 6, choose 2.
You're just jealous you don't have a shirt like this.
Not so much.
Times 4. I messed up that.
One thing I hope you might have also noticed, when you're choosing 6, choose 0, what is the secondary term's exponent? I want to show you this. When this is 0, this is 0. When this is 1, this is 1. When this is 5, this is 5. When this is 4, that's 4. It's a nice little pattern that happens. And then the other term would just be however it makes it take you to get back to the 6. 2 plus 4 is 6.
I don't like
1 plus 5 is 6. You should never get these types of things wrong. They're fun. We
They're not fun.
put the fun in functions.
Wow.
So we have x to the 6th plus, we have minus, 6 choose 1 is, wait, isn't it 6?
6 choose 1 is 6, yeah.
And then 6 times negative 2 would be negative 12, x to the 5th.
Wait, 6 times negative, oh, that's where I messed up.
6 choose 2 would be 6, 5, be 15.
6 choose 6 is
15 times 15 times 4 would be 60.
6 choose 2, they do like 6. 6 choose 6 is 1.
What was that, sorry?
How do you do choose 2?
It'd be 6, 5, 3, 2, 1 over 4, 3, 2, 1, 2, 1. That's 6 minus 2. So basically your numerator becomes 6 and 5 over 2. So it's 3 times 5. Okay. It'll be a minus. 6 choose 3 would be 6, 5, 4, 40.
That's fine.
Is that right? 40 times be negative 120. 6 choose 4.
Wait. That'd be negative 320.
Yeah, I got negative.
Negative 2 to 3 is negative 8. Times 40.
Oh, yeah, you're
I got 60, but I haven't been doing stuff right.
all right. 6 choose 4 is the 6, 5,
It's
the 15 again. Yeah, 15.
Yeah.
15 times.
16.
I don't know.
16. It's 240.
40.
Are you sure it's minus 320? Because I got minus 160.
I got minus 160.
Yeah, it's minus 40 times negative 8 is 3. Negative 3. Where did you get 40?
It is 160, isn't it?
I got 40.
Look, I'm just listening to you guys. I don't know. I just work here.
You said 40 somewhere.
Seriously, you guys have calculators. Press the buttons.
I had x squared minus 12x plus 60x to the 4th minus 160x to the 3rd plus 240x squared minus 1 minus x plus
20. It's 20. You said 40, so that's why I said it was negative 320.
Negative 160 here.
I was right. See,
Mr. You said 40! Let's be like, hey guys, I use the calculator. I always talking to you.
I'm pretty sure it's because he's trying to get, because they're trying to bribe you because they're Should I accept the
I'm so upset.
I thought you said you were cool.
I was.
I think Naomi is the one you need to worry about throwing a chair.
I'm gonna run a chair. We're throwing a student. Already have a list.
We all right?
Everyone's got
Yes, everything's fine. I like how
Yes, worksheet.
Do this work on the paper you did from last night that we have room. Maybe we want to go double or nothing?
Yes. No.
Wait, no.
Ellie, don't even talk to me.
Every time.
Nobody wants to go double or nothing?
I'll allow us to play.
Wait, what do you play?
Oh, so if you double, we're gonna play.
You guys get the Xbox, you can't do 21.
And I was thinking it was called goldfish, but it's really gold.
Double the homework, double the punches.
Sure.
E and C.
Yeah, let's do it. I kind of remember.
Both sides. Wait, what?
Wait,
Swole D double.
so what says B?
The one that says practice B.
I know.
You're doing the same numbers on both sides all the time.
Oh.
That's kind of odd. 9 is a different section. Do you know if there's
Who?
Oh my god, there's 3 months until like
Those are just some overgraph cards?
Oh my god, there's like.
Can we play straight and go fish?
No.
How do you play fish?
Play go fish while you're outside surfing.
Oh, okay.
And you're trying to actually catch fish. Like you can't keep going on unless you catch fish.